Section 9.7, this is going to be all about different types of math that we can do with our matrices. So first of all, let's just get a couple of basic definitions out of the way. If I have a matrix that has the same number of rows as it has columns, this is called a square matrix. Sometimes we say that has an order of n. So if it's a 2 by 2, we would say that the order is 2. And again, the rows is equal to the number of columns. A matrix that only has one row is called a row matrix. A matrix with one column is just simply a column matrix. If two matrices are considered equal, then that means that they have the same dimension and all of the corresponding elements position by position are going to be equal to each other. So for example number 1, find the values of the variables for what makes the statement true. So in this particular one, since the variable a is in row 1, column 1, and -3 is in row 1, column 1, then we would say that a is equal to -3. B is equal to 9 because they're in the same position. C is equal to -5 because they're in the same position, and D is equal to 0. For part B, we would say that these are not equal to each other because they are not the same dimension. So remember, they are equal if they have the same dimension. And this first one is a 1 by 2, whereas the second one is a 2 by 1. So they are not equal to each other. All right, we can add or subtract matrices by simply adding or subtracting all of the corresponding elements. Once again, they have to be the same dimension in order to be allowed to add or subtract them. All right, so for example A, here in example 2, part A in example 2, we take row 1, column 1 plus row 1, column 1, and we're going to get a 3 plus a 7, which is a 10. Row 1, column 2 plus row 1, column 2 is going to be -8 plus -5, so that's going to be -13. Go down to the second row, and -4 plus 10 is 6, and 6 plus -6 is going to be a 0. For letter B, for example B, we've got 9 plus -9, which is going to be a -18. And then 7 plus 5 is 12, 6 plus -6 is 0, and -3 plus 10 is going to be 7. When we look at part C, it's asking us to add A plus B, but A is a 2 by 3, B is a 3 by 2, so we would say that we can't add these. All right, with subtraction, this is going to work the exact same way. So pause the video, see if you can find the answer to parts A and B, and then unpause it, and I will hide the answer. All right, so now that you're back, what we've got here is this is the answer to part A. Check yours and see if you got the same thing. And this is the answer to part B. Once again, for part C, they're not the same dimension, so it is not possible to subtract matrix A minus matrix B. All right, scalar multiplication. Scalar just means a single number, and so we're multiplying a single number by a whole entire matrix. When we have scalar multiplication, all we're going to do is distribute whatever that number is. So for part A here in this example, we'll distribute the -3 to each of the pieces. So you have a -3 that's going to be multiplied by a 2, which is -6. Multiply it by -5, that'll be +15. Multiply it by -4, that'll be a 12. Multiply it by 0, and you will get 0. For part B, this time we're multiplying something a little bit more challenging. We're multiplying a fraction. Think of this, though, simply as each of these numbers, divide them by 5 first, and then multiply by 4. Let me show you what I mean. Take a -25 divided by 5. That's -5. Now take your -5 and multiply 4, and you're going to get a -20. Do the same thing with all 4 of those positions. So just divide 5 first and then multiply by 4. And that's an easy way to multiply by a fraction, and you don't even need a calculator to do that. So that's when you multiply a number by a whole matrix. What do you do when you have two matrices that are being multiplied together? Well, we have some rules on this first of all. So the number of columns has to match the number of rows when you're doing, in this particular case, A times B. So what happens is the way that I like to write it out here, and I'm going to write it out underneath. If you have an n by n matrix and you're going to multiply by an n by p matrix, the first thing you got to understand is that these two guys must match. They must be the same number. And not only that, the outer numbers, this is going to be the order of my answer. It'll be the dimension of my answer. In this particular course, we're going to be using the calculator on these. All right, so deciding whether two matrices can be multiplied in the first place. So if you have matrix A is a 3 by 2, matrix B is a 2 by 4, the first thing you ask yourself is, do the inner numbers match? Yes, they do. So can it be calculated? Yes, this one can be calculated. What is the order or the dimension of the answer? It's going to be a 3 by 4 because that's going to be those outer numbers. Can B times A be calculated? So in this case, it's a 2 by 4 times a 3 by 2. Notice that my inner numbers do not match each other. So we would say here, no, you cannot multiply these together. I don't even need to get a dimension. You can't multiply them. All right, so I'm going to let you pause the video and take a look at how to, you already know how to enter the matrices into your calculator, but notice once you have those matrices entered into your calculator, the only thing you're going to do is you're going to use the names column. And you're just simply going to take matrix A times matrix B, whatever it was that you put into your calculator. So on this one, I'm not even actually going to show you on the screen. Just follow the instructions. It's quite simple. So for example number 6, part A, we've got, first of all, a 2 by 3 times a 2 by 2. And so since my inner numbers don't match up, we would say this one is not possible to find a product. However, if I do B times A, this is going to be a 2 by 2 matrix times a 2 by 3 matrix. And so my answer is going to be a 2 by 3 matrix. So go ahead, put B into your calculator, put A into your calculator, and then go to the names column and just simply do matrix B times matrix A. Make sure you put matrix B first, and you should get a 2 by 3 matrix. That is this one right here. For example number 7, multiplying square matrices. And so same thing, but since they're square matrices, since they're both a 2 by 2 here, I am able to easily multiply these. Again, we're going to do these in the calculator, so pause the video, take some time to enter C into the C matrix on your calculator, enter D into the D matrix on your calculator, and notice that my letters here are incorrect. So first of all, this should be C times D, and this one should be D times C. So make sure you fix that. Otherwise, that's not going to make a bit of sense. All right, so we multiply those together in the calculator, and these are the two answers that we should get. One of the things that Lyle points out here, the author points out, is that matrices are not commutative, so trading the order does not yield the same matrix. So just be aware that C times D here is not the same thing as D times C.